All right, welcome back. This is Bill Westlake at LagDemon Programming. Thanks for watching. I hope you're enjoying the videos. Last time we ended up creating our tokenizer for our rock, paper, scissors game. And now the user can enter one of these commands, and we read it, we trim it, and we tokenize it, and we get back an appropriate token for as long as they typed one of these things in. Now, we're not going to process that token just yet. We've got the user input getting a token from the user, and we're going to turn this into a function at some point. But what we want to do now is let the computer be able to make its choice. And we're going to do that using random numbers. And to do that, to use random numbers, we're going to need to include two more include files from the library. And I'll just copy these as it's easier, and I'll explain them. So this is the C standard library and C time. We're going to use time to seed our random number generator. If we didn't seed it, every game would be exactly the same, and you would be able to predict very quickly what the computer was going to do. So we've got and the standard lib contains rand also. This standard lib contains our rand function and various supporting functions for it. So the first thing we want to do is seed the random number generator, and we're going to do that right here just at the top of main for now. We'll eventually reorganize a lot of this, but we're going to go into the standard lib again, and we're going to get SRAND, SRAND. SRAND is seeds the random number generator system, and it's just kind of a global seed. Whenever you call rand, once you've seeded it, this should work. It will work. And we're going to go back to standard again and get time and just pass it a null pointer, because we don't want the actual time we don't want to do anything with the struct in here. We're just going to pass that in. This will send a time number, time t, into srand, and it'll be seeded with a number associated with the exact time when we ran this program. So in order for the computer to choose a number, we need a function, and we want that to return tokens, and we're going to call this random token. And I'm going to put a note here that this random token only selects rock, paper, or scissors. So the computer has no need to cause a quit or get help. It just needs to select one of these three. This is also why I put the rock, paper, scissors first. And we probably don't really need that, but we can leave it here. So because it's going to choose 0, 1, or 2, it's not going to choose 3 or 4. Now, how are we going to do that? All right. We're going to do that with a random function. I just want to glance at my notes. I'm pretty sure I know how to do it, but I prefer not to be just randomly doing stuff. I think to go by my notes. All right. So first I'm going to break this down in little parts. So we're going to do an int, and we're going to call we'll call this pick equals rand. And if we do that, rand is going to generate a number that's an integer that can be a very big number, but we only want a 0, a 1, or a 2 for rock, paper, or scissors. So the simplest and easiest way to do that is with a modulo operator. If we do that number, that integer number mod 3, this is the remainder of a division by 3 of whatever number that is. And that remainder will always be 0 or 1 or 2. If it's exactly divisible by 3, great, we'll get a 0. So if it's 9, we'll get a 0. If it's another number, we'll have a remainder, and that remainder will either be 1 or it'll be 2. Will be left over from the division by 3. I'm sure you can see how that happens, right? Because if there could be a remainder of, say, 3, well, then if 3 is the number we're dividing by, so there can't be a remainder of 3, because if we went 3 forward, it would still be divisible by 3. We'd still get an even division, okay? So it's always going to be less than 3. It's going to be 0, 1, or 2. And then what we can do is do our tokens result equals, we're going to use that static cast again, this time to tokens from pick, and then we can return the result. So I wrote this all out so that we could see the steps and see what's going on. We're getting a random number. It's 0, 1, or 2 because we're doing modulo 3. This is there's another name for this, and sometimes it's called clock math. It's just going to rotate through those numbers. It can never escape out of 0, 1, or 2. And then there's another mathematical name for it that's used a lot in functional programming. And at some point in time when we talk about the functional capabilities in here, I'll talk about those ideas and those concepts mathematically, as well as what they mean in terms of programming. So we can do a little refactoring of this, though. Pick here is just this. So we can just pass all of that into pick and get rid of this local variable. We don't need it. So we can just call this function and pass it into the static cast and get a result. And that result, all we're doing here is returning the result. So that's equivalent to just doing a return and getting rid of this return. So that's our random token function. It goes out, gets a random number, does a modulo 3 on it, gets a number 0, 1, or 2, static casts that to tokens and returns the token. This function is guaranteed to always return either rock, paper, or scissors, and nothing else ever. It can't return anything else, and it must always succeed. There's no reason for it to ever not succeed. So we've got our computer's ability to select a random number now. Now we want to evaluate a very simple rule. And the very simple rule we all know. We've probably played rock, paper, scissors, right? If I have a rock and you have a paper, we say that the paper wraps the rock, so paper wins. If I have scissors and you have paper, scissors cuts paper, so scissors wins, and so forth. And then, of course, there's rock and scissors. The rock breaks the scissors, so rock wins. And anytime you have both the same, rock, scissors, scissors, paper, paper, it's a draw. So there's 3 possible outcomes. And those are player wins, computer wins, or a draw. So I'm going to come back up here and I'm going to create another of these enum classes. And I'm going to call it, what did I call it up here? I think I just called it winner. Winner, I did. And a winner can either be the computer, the player, or a draw. So whatever a winner is, actually, you know what? I'm going to call this, instead of winner, I didn't like that name at the time. I'm going to call this just play result. So whenever there's a play result, and it's either the computer, the player, or it's a draw. All right. So how can we codify this rule? All right. So we want to return a player result. And this function, we're going to call this, we'll call it compare. We'll call it check. What do we want to call it? So we're going to compare to, so compare selection. Compare selection. All right. So we will have a tokens, and we'll have it the player, and we'll have tokens, and we'll be the computer. So we'll send a player selected token into here and a computer selected token into here. And if player equals computer, we're just going to return play result draw. That's easy. Now we're going to do what's called a switch statement. And a switch statement allows us to check against various values. Well, do we want to do a switch statement? We already did an if statement for if they're the same, it's a draw. So we're just going to return a draw. You know, something else we should probably pass into here. Did we do a score struct? We did. We've got our score struct. This function could also apply the score. No, we'll do that in a separate function. All right. Let's do this. Well, we can do a series. Instead of, we can do a, let's do a switch statement. Switch on the player case. So a switch statement says, look at this player and run whichever of these cases the player matches. And you can do this with enumerations and class enumerations and a few other things. You can't do it with every type of variable. It has to meet some criteria. And we'll talk about that down the road. So we've got tokens, rock. Then we could do another switch statement on computer. Oops. Let's move this down here. And we can go tokens, case, tokens, it's a rock and a rock. If it's paper, return play result, computer wins. Why? Because if I've got rock and he's got paper, paper wraps rock, so the computer wins. But case, tokens, scissors, colon, do a return, play result, player. All right. Now we've got this switch statement and this switch statement. So here's one case. We can duplicate it. If this is paper and this is actually, you know what? We don't want to do this. We need to cover all the cases in here. So we'll do rock here. So we've got rock, paper, scissors. It's rock and rock. We return a draw. And we'll move this rock down here. If it's paper, rock, player wins. If it's paper, scissors, computer wins. If it's paper, paper, it's a draw. So we're building out the rules here, right? Now we've just got really one more to do here, right? This case, this down here, rock, paper. So if the player's got scissors and the computer's got a rock, the computer wins. Paper, the player wins, and scissors, it's a draw. Okay, let's double check this little algorithm here. This is our rule. It's our game rule, basically. And it's saying that, 1 second, 17 minutes. Okay, we're good. This game rule is saying we've players made a selection, the computer's made a selection. We're gonna run it through this algorithm. If the player's got a rock and the computer's got a rock, it's a draw. Rock, paper, it's the computer, because paper wraps rock. If it's scissors, it's the player. And you can see it changes around. If it's paper, rock, it's player. If it's paper, paper, it's draw. If it's paper, scissors, it's computer wins. So we've got it. Scissors to rock, computer, scissors to paper, player, scissors to scissors, draw. Okay. So let's, after getting the player token, let's do a test again. We'll say tokens comp equals, what did we call that random function? Random token. So this is the computer selecting a token, and then we'll go what do we call this one? Compare selection. So we'll go play result equals compare selection, and the first one is the player, which is the token, and then the computer. So we have a player result. And we'll put result in here, and that win, where did I put it? Player result. Computer is 0, player is 1, draw is 2. So we could do a quick convert to string for that, to say which one is the winner. In fact, let's do that. Let's just go standard string. We'll just call it to string play result. We'll do a switch statement on play result, case, play result, computer, return, computer, case, play result, player, we'll do a return, player, and case, play result, draw, we will return draw. All right, and I like these indented away from those. And so instead of static cast here, we'll say toString. We'll name that better later, but at least it'll tell us in our one pass thing here who won. Works. If I select R for rock, hit enter, player won. Let's run it again. We'll check rock again, player won. Let's try rock again, computer won. Okay, so it's definitely randomly selecting our draw. Okay, so that part's working. 21 minutes. All right. Let's go take a look at our requirements here. Display prompt to user. Check. Let's put an X. Put an X here. Okay, we did that. Read line, we did that. Process user input, quit or help. We really haven't completed that. We haven't done the exit game or the help step yet. And we're not computer randomly select. We're not completely processing this, so I'm not going to check that off yet. Computer randomly select a rock. Yeah, we got that. We can do that. Compare and determine winner and draw. We did that. We have to accumulate the score and display the results in a better way than we are and go back to one. So we're almost really finished. We want to do a little bit more processing of this. We want to check that token for the quit or the help. What are we doing with that? So we're tokenizing it and we're getting the quit or help. That's what we're not really interpreting the token. We're sticking the token straight into this compare. And really, that's not what we want to do, because this could be a quit or a help. So we're going to need a step in here right after this to say, yeah, we can do a switch on token, and we'll just do the case of tokens : quit. That's easy. Colon. We're just going to return. We'll return 0. And case tokens : help. I'm going to put a note here. Actually, right now, what we're going to do is actually, we're going to put this whole thing in a loop. Let's go while. Let's start off with bool running equals true, while running. So this is a while loop, and I'll explain it in a second. I'm going to go down here to the bottom, put that in there. If we get a help, we're going to say help, and then continue, break. I don't think we need the break, but we need a help function. So what we'll do is we'll just go void help, and for the moment we'll just do something like this. We'll just say game. So if you ask for help in this game, sorry, I just had to do something. It's going to say, really? You need help with this game? From why is it not like that? Oh, and L. All right. So we'll call help and continue, which will continue the loop and display the prompt again without doing anything else. And otherwise, so it's not quit, it's not help, it must be a proper token, and we can come down here and process it. And now it will keep running, except when we go quit, well, we return 0. So actually, I could have just done while true. We don't need this, because when we type in Q or quit or whatever, we're going to return 0 and the program's going to exit. Let's test it and see how it works. We've just about got our REPL loop working here. So let's go R for rock, computer, R, draw, player, 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 draw, 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 computer, draw, quit. Quit works. Let's run it again. Let's try the help. Help. Really, you need help with this game? Q to quit. So we have, so let me just kind of overview this. We've still got to do the scoring, which we can do very quickly here. Let's see how we're doing on time. 27 minutes. Yeah, let's do the scoring really quick. So with the player result, this system here is what's called a REPL, a read, eval, process, and loop. We're reading something from someone or something. We're doing some evaluation of that thing that they typed. Not process, but print. We're printing out some sort of result, and then we're looping back. That's called a REPL, R-E-P-L. All we have to do to compute the score is take this play result and we want to create a score object first of all. So let's do this. Let's say score. So we've got a score object we can pass in each time, and let's just create a function called score. Void score result. Did I call that score? Yeah. Oh, score T. I've been using the score T. We probably should use that. Score underscore T. Score. Void. Score result. And we want to pass it in a play result and a score T ampersand score. So we talked about this. We talked about references. This is not a constant reference because I'm going to update the score. This is going to pass in the score, and we're going to call score result right after we get the random token and the play result. Okay, so now we're going to call score result, and it's going to be result, comma, score. And then we can output the results here. So let's do the score result, and let's go switch. Oh, we got to give this a name. Play. switch play, and it's going to be play result, excuse me, case play result, computer colon score dot computer plus plus break, and case play result colon player colon score dot, I call it user plus plus break, and case play result colon draw will just break and do nothing. Alright, then we can output the score each time. So here we can say, instead of result, we can say the winner is, and the standard C out the score. The score is, so here in America it is Memorial Day weekend, and a bunch of people were outside shooting fireworks when it got dark, and it's late at night, and I had to wait until the fireworks were over because there was a lot of booming and banging going on with people celebrating Memorial Day a couple days early, which is fine. I don't object to their celebrating, but it's late for me right now because I had to stay up late until everybody was done shooting fireworks. So we'll say player dash score dot user from here end L. All right, and I'm going to put a tab in here. I'll copy this. Actually, I'll just space it in a little bit, because then I'm going to get rid of this and space this in a little bit. Computer, we'll move this over. Computer, these were supposed to be NL and L. And I think our rock, paper, scissors game is done in 2 videos. That's not too bad. Rock. Oh, it was a draw. I'll just keep hitting rock. Computer, and computer scores 1. Another draw. Computer scores 2. Another draw. Another draw. Computer scores 3. I'm not getting very far just hitting rock. I'll just hit it a bunch of times here. Computer's just beating me. And actually, this is probably correct. You could probably work out over a lot of plays what the probability of winning is if you always select the same one, with it randomly selecting another one. Let's try scissors for a while. Interesting. Sending nothing in. Anyway, there is rock, paper, scissors. This will be this bit of code here. If you want to take a look at it, it'll be posted up on GitHub. Yeah, thanks for watching. I hope you enjoyed the video. If you really liked it, hit that like button. If you want to subscribe, we'd be more than happy to take subscriptions. You know, watch the channel often and watch for those updates. Hit that update button and get notified when I upload videos. Also, I have another playlist on Unreal Engine 4 game development, And if you're interested in that, take a look over there. We don't do a lot of C++ on that side yet, but we will be doing it soon in the Unreal Engine 4 C++ mode. So thanks for watching. I hope you enjoyed the video, and have a great rest of your weekend or week or whatever it may be. Thanks for watching. I'll see you in the next video.